Hi, everybody. I am back, and today I'm going to be doing a little intro to probability. So, we're looking at probability and statistics, and what we're looking is how do we go ahead and do an analysis of occurrences and events to then make a valid hypothesis, and either we test it and we direct it based on the probability analysis that we created. So, some terms that we like to go over first is the event is any data collection or result. And this can also be considered outcomes of a procedure. So I do have another term is sample space. And sample space is kind of like the data set, and the set number when we compare it back to our previous notion of stats. So these are all possible events linked to whatever you're doing. So with the example, I'm going to go ahead and look at tossing a coin and also tossing two coins. So tossing a coin is the action, and my sample space is heads or tails. Why? Because when I toss a coin, I can either have heads or tails, nothing else. Okay. And so in this particular example, I can see that the event is heads. Another possible event is tails. So anything that's in the sample space in a singularity is going to be the event. So now here I go with tossing two coins. What happens when I toss two coins? Well, now my sample space is larger because now I have a couple more outcomes than just heads or tails. When I toss two coins, I have to record the occurrence. So I toss, I flip it, I get heads, heads. I can also get tails, tails. I can also get heads, tails, and I can also get tails, heads. So any one of these is an example of an event, but these entirely as a whole is a sample space, which means for this act right here, I know that I have all of these occurrences. There's nothing else that can happen. Okay? So now moving on to some probability notation. P means the probability of, and A, B, C, D, E, all different events are the actual events. Okay? So let's look at what it reads. P of A means the probability of event A occurring. Okay? So now let's talk about the boundaries of probability. This means that probability values can only range from 0.000 to 1.000. Okay? It cannot be negative and it cannot go over 1. Why? Because this is how occurrences and probability analysis take place. It can either have a probability of impossible, which is 0%, or a probability of it will happen, guaranteed to be certain, at 100%. Then you have an infinite amount of values between 0 and 1, which is your probability boundaries. So the closer you are to 0, then that means that your event is probably not going to happen. The closer you are to 1, that means the event is much higher, has a higher likeliness or likelihood of happening. Okay? All right, so now let's look at this here. Sorry. Here. I'm just giving you some examples that will help us read the notation and tell us how to recognize what these numbers are. So P of A equals 0.17. What this means is the probability of event A occurring is 17%. Again, if I look back at that range here, 17% is over here, so it's in the unlikely area of that range. Similarly, P of B equals 0.83 when I translate it into English means the probability of event B occurring is 83%. And 83 is likely because it's in that range over here of likelihood. Okay? So looking at the multiple representations that we have, P of A equals 0.17. This decimal representation can be turned into a ratio. And this ratio now tells us that in a sample space of 100 events, 17 of those events were event A. Okay? So let's look at what that means. So this ratio representation is literally how we calculate probability. We look at one simple event A, and the numerator will always be how many times did A occur in that sample space denominator is how many events were there in the sample space. And this ratio will give you a ratio that will then turn into a decimal, and that's going to give you that decimal then turns into a percent, and that gives us some form of data showing the occurrence and the likelihood of that occurrence in happening. We also have something called subjective probability. And subjective probability is establishing a probability estimation based on known facts. So I'm going to give this example. What is the probability of Chris winning the lottery? We don't know what things are other than a couple of things. We know that millions of people play the lottery. For this example, we said 10 million people, just, ballpark figure. Chris only spends $3 when he plays. So that's event A is three of them, right? Because every time I play the lottery, that's $1 and he plays $3. So then there's 3 possibilities out of those 10 million that Chris wins the lottery. So again, I'm setting it up. Event A, which is Chris winning playing the lottery, right, is 3 over 10 million, the amount of people playing the lottery, including Chris. That translates to this on the calculator, which is scientific notation, which really means I take 3.0 and then I move the decimal 7 times to the left. So this right here is truly the probability of Chris winning the lottery is 0.000003. That number is hella close to 0, which means he's highly unlikely to win that lottery. All right. Now let's talk about complements, okay? So we're talking the complement, and we recognize that P of A is the probability of event A occurring, but now I put a little dash on top of that, and now this reads P of A naught, which means P of A naught is the probability of event A not occurring. So if we think about it, right, if we look now at the complement rule, which means if something is white, then something is not black. And if something is black, then something is not white. I'm looking at that comparison there, right? So if I have something, this is the complement rule, which says the probability of A not occurring is equal to 1 minus P of A. And this 1 comes from this guy right here. This 1. 1 is the totality of my sample space. So that's what 1 means. So A naught is 1 minus whatever A was. Is going to give me the space or area that is represented of not A. Okay? So let's look at a little example, and with this I end. So I said a weighted quarter has the following probability. It's a weighted quarter, which means the weight is not equally dispersed in the coin. So based on a certain amount of trials, we recognize that the probability of landing heads is 71%. What's the probability of landing tails? So again, it's a coin toss situation. My sample space is heads or tails. So that's the only 2 occurrences I have. I don't have anything in between. So here, I am able to use the complement rule to figure out what P of T is. So to find P of T, I need to recognize this little situation here, which means heads is equal to or equivalent to not tails. Is that true? Is heads not tails? Yes, that's true. Similarly, is tails not heads? Yes, that's also true. So we recognize this because I'm going to use that in this logic to prove that I'm able to use the complement rule to figure out what the probability of tails is. So I recognize that probability of tails is equal to the probability of not heads because tails is equivalent to not heads. So now I see that I have the probability of A naught or an event not, which is, I'm going to use this rule here. So probability of not heads is equal to 1 minus the probability of heads. So I know the probability of heads is 0.71. So 1 minus 0.71 gives me 0.29. So now I figured out that the probability of reaching tails or landing tails is 0.29. but we must also identify this in the representation of analysis. The probability of landing a tails is 29%. That right there is an introduction to probability. Stay safe, everybody.